Human. This is a continuation of the previous video. You are supposed to have done this already. In this question, we need to use the ladder method to prime factorize. We need to prime factorize 36, 180, and 1260. I will break this down for you. I will start with prime. This is from prime numbers. Define it for me. What are prime numbers? Prime numbers are numbers that have only two factors. They only have themselves and one. So those are the only two factors they will have. The number itself and one. Give me an example of these prime numbers. It is 2, 3, 4. No, 4 has multiple factors, so it's not a prime number. Can 5 be a prime number? So the factors of 5 can only be 5 in itself, right? What's the next prime? 7. What's the next prime? 10? No. 11. It has two factors, itself and 1. And then it goes on and on and on and on. Please watch the movie, Hidden Figures, and just watch the first 10 minutes of the movie. You'll see something very interesting there. It's called Hidden Figures, okay? HIDDENFIGURES. Okay. Just watch the first 10 minutes of the movie where it starts. You'll see something very interesting there. You'll love it. Now, when I prime factorize 36, I will choose the lowest prime that goes into 36 without leaving any decimal. And the lowest prime that goes into 36, I'm always guided by the last number. If I see the last number is 0 or an even number, I know 2 can get into it. Hence, I chose the lowest prime, which was 2. 36 divided by 2 will give me 18. Another even, so 2. 18 divided by 2 will give me 9. Now I can't use 2 anymore. You always start with the lowest, guys. When I mark, I see stuff everywhere. It's because people don't listen. You start with the lowest prime. In that way, you will not make mistakes. Now, the lowest prime that will go into 9 after 2, can it be 5? No, it is 3. Lowest. 5 is bigger than 3. You start with 3. If it doesn't work, you go to 5. If it doesn't work, you go to 7. You don't just start with the biggest prime. You start with the lowest primes first, guys. The lowest prime that will go into 9 will be 3. 9 divided by 3 is 3. The lowest prime that goes into 3 is 3 itself. 3 divided by 3 is 1. Good. That was great. Let's do 180. What is the lowest prime? 2 is correct. It gives you 90. 180 divided by 2 is 90. Then you divide 90 by 2. It'll give you 45. Then you divide 45 by 2. No. If you take 45 and you divide it by 2, it'll give you 22.5, which is a decimal. So it can't be 2. Can it be 3? No, it's 5 actually. No, guys, it's not 5. 3 does go into 45. So let's see. 45 divided by 3, what is it? It is 15. Can I go into 5 now? No, I can still use 3. 15 divided by 3 gives you 5. Can I divide 5 by 3? No. I go to the third lowest prime, which is 5. 5 divided by 5 gives you 1. That's it. All right, I've done the first two. Try the last one. Lowest prime, it is 2. 1,260 divided by 2, it is 630. The lowest prime, it is still 2. 630 divided by 2 is 315. Because this number, the last number is an odd number there, you know that it can't be 2 that goes into 315. Let's try 3. 315 divided by 3, it gives you 105. Can 3 go into 105? It does. What is 105 divided by 3? It is 35. Can 3 still go into 35? Yes, it does, right? No, it can't. So 3 doesn't work anymore. So we've done 2, we've done 3. 3 is not working anymore. So what's the next prime must we try? Can we try 7? No, we start with 5 first. Can 5 go into 35? Yes, it does. How many times? 7 times. But the thing is, 5 can't go into 35. So let's try the next one, which is 7. 5 can't go into 7, sorry. The next prime that goes into 7 will be 7. All you have to do is to take all your products and write them as a product of vectors. So 36 will be 2 times 2 times 3. In exponential form, it will be written as 2 squared times 3 squared. So we're multiplying 2 by itself. How many times? Twice. So we write it as a base of 2 raised to an exponent of 2. We're multiplying 3 by itself twice. So we write it as a base of 3 raised it to an exponent of 2. Okay, got it. You sure? Sure. Can I move on? 180 will be 2 squared times 3 squared times 5. If you're wondering why am I taking this 2 multiplied by 2, I got it from the table here. I'm simply taking all these prime factors and I'm multiplying them, okay? So for 180, it'll be a product of all these prime factors multiplied. When you multiply a number by itself, you keep it as that number and you just add the exponents. Exponent indicates how many times that number has been multiplied by itself, okay? And for 1,260, I will get 2 squared times 3 squared times 5 times 7. To get my LCM, I like the way my grade 8 say it. To get your LCM, it's all the factors raised to the smallest exponent. All the prime factors raised to the smallest exponent. So let's take 2 for example. The lowest exponent of 2 is 2. So 2 will be represented and its exponent will be 2. What about 3? 3 will also, its exponent will also be 3. And 5, its exponent will be 1. And 7, its exponent will be 1. You always choose one vector, but you always, if it's common, you take a vector with the lowest exponent. You got that? And our lowest common multiple here will be 1260. The highest common factor, here you only look at common, meaning they have to be in all the products that you're given. So is 2 a factor of 36? Yes. Is 2 a factor of 180? Yes. Is 2 a factor of 1260? Yes. So that 2, we say it'll be part of the highest common factor, and you always choose the 2 with the highest. No, actually, I'm lying here. In LCM, it's a base with the highest exponent. I got that one wrong. It's a base with the highest exponent for LCM. But for HCF, it is the base with the lowest exponent. I hope I didn't confuse you there. I will repeat. With LCM, it's a base with the highest exponent. But with HCF, it's only a common base, not all the bases, it's only a common basis with the lowest exponent. And here, the lowest exponent of 2 is 2 itself. Can 3 be part of HCF? Let's see. We've got 3 there, we've got 3 there, we've got 3 there. So it is in all the product. But we will take the 3 with the lowest exponent. In this case, it's just that 3 to the exponent of 2. Can 5 be part of HCF? Oh, we don't have 5 there. And that's a problem. So it's not common. So it can't be part of HCF. Can we have 7 as part of HCF? We don't have 7 there. We don't have 7 there. So it can't be part of HCF because if it's not common. So for HCF, you will only have 2 squared times 3 squared, which will give you 36. It'll be 2 squared times 3 squared, which is equal to 36. And that is 4 times 9. It's 36. Got it? Good. All right. Let's move on to this one here. They want us to find the square root of 9,604, but we first have to do it without using a calculator, but you have to use the ladder method. You will start with what is underneath the square root, which is that 9,604. Take it and divide it by the lowest prime, which is 2 here. 1,604 divided by 2 will give you 4,802. The last number there is an even number, so I can still use 2 divided by 2. It'll give me 2,401. Now the last number there is odd, so I can't use 2 anymore. I'm going to try 3. When I try 3, it gives me a decimal. Okay, let's try 5. 5 also gives me a decimal. Okay, the next prime after 5 is 11. Oh, it is 7. So let's try 7. 2,401 divided by 7 gives you 343. Divided by 7 again, it does give you 49, which can be divided by 7. It'll give you 7. And 7 divided by 7 gives you 1. Write that as a product of prime factors. So you will have cos 2. There are only 2's here multiplied. It'll give me 2 squared. And 7's are multiplied by themselves 4 times. It'll give me 7 to the exponent of 4. Now, when I got to sets, people looked surprised. And I'm like, why do you look surprised? So what we can do here is to distribute the square root. We give the base of 2 its own square root, so it'll be 2 squared, the square root of 2 squared times the square root of 7 to the exponent of 4. So you give each base its own square root. The square root simply tells you to take the exponent of the base, and you can only do this across multiplication and division. You can't do it across addition or subtraction. You may not distribute the root across addition or subtraction. You can only distribute it across multiplication. Please don't forget that, okay? So the square root tells you that you need to take the exponent of the base and divide it by 2. So I'm going to take 2 and take its exponent, which is 2, and divide its exponent by 2. Do the same thing with 7. I'm going to take 7 and take its exponent of 4 and divide it by 2. Okay. So I will end up having, I don't know why I wrote equal here. It's multiplication. I will end up having a base of 2 to the exponent of 1 because 2 divided by 2 is 1 multiplied by a base of 7 to the exponent of 2, which is the same as 2 multiplied by 49, and 2 multiplied by 49 will give me 98, which is my final answer. You got it. You sure? Try this. So what are you going to do? You will take what is underneath the cube root, which is 3,375, and prime factorize it. How do you go about doing that? You divide it by 2. Oh, 5. Okay, how much then? You divide it by 3. 3,375 divided by 3 gives you 1,125. Should I move on and divide it by 5? You try 3 again. It'll give you 375. 3 again. It'll give you 125. 3 again. It doesn't work this time. Let's move to the next prime, which is 5. 125 divided by 5 is 25. Divided by 5, it is 5. Divided by 5, it is 1. You will write this as a product of its prime factors, which will be 3 to the exponent of 3 times 5 to the exponent of 3. Because we are dealing with a cube root here, you are going to take exponents that are inside the root and divide them by 3. 3 divided by 3 gives you 1. 3 divided by 3 also gives you 1. So you'll have 3 to the exponent of 1 times 5 to the exponent of 1. And 3 times 5 gives you 15. So the cube root of 3,375 is 15. That was question 2. Try question 3. All right. See you in the next video. Kalibitso ke? Re filo di chamel.